Before I begin with the exact lesson about monomials and polynomials, I want to illustrate or make clear a theme that we're going to refer to regularly in this entire unit. And we've already had some experience with it. The point I want to try to make is that what we're going to be learning in this unit are patterns that are true regardless of what values for the variable we plug in. In other words, how to compute with variables. So we already know that 3x plus 5x equals 8x. That's called combining like terms. We'll be doing more of that. And the reason why it's true is because I can pick any value for x. Let's just make x equal to 4. But anything would work. If I say 3 times 4 plus 5 times 4 equals 8 times 4, it will definitely be true because that's always true when we combine like terms. 12 plus 20 equals 32. I want to lay that as the background of everything that, a whole lot that we're going to be doing throughout algebra. Take, for example, so let's just expand that idea of like terms. If I say 3x squared y plus 5x squared y, these are like terms because here's the very scientific definition, if I take away the coefficients, they look exactly the same. That is a definition of like terms. 3x squared y plus 5x squared y. Just like 3 times a number plus 5 times a number gives me 8 of the number, this x squared y represents a number. So if I have 3 of them and I add 5 of them, I've got 8 of them, 8x squared y. And just like in this example, if I chose numbers to plug in for x and y, 3x squareds times 3x squared y's plus 5x squared y's would give me 8x squared y's. Notice that that is not true if I say 3xy squared plus 5x squared y. Let's do our very scientific test. When I take away the coefficients, do I have exactly the same thing? The answer is no. An x times a y squared is a different number than an x squared times a y. So I can give this any coefficient. And the thing is, I cannot simplify these because they are not like terms. In fact, they are called unlike terms. You cannot combine. Unlike terms. So let's look and see what that ends up looking like in terms of monomials and polynomials. So let's move on to polynomials. You can hear something in the root word of these. If I say monomials, it's got the word mono, and they are expressions with one term. And part of this, you got to get used to what it looks like. It could be a number, or we call them a constant. It could be a variable, or the product, and this is important. Product means multiply of a number, there's always only one, and variables. So let's look at some examples because this has some key little parts. Here's an example, the number 3. It's a monomial. It actually has a special name, a constant monomial. The variable x, or the product of 3x squared y, for example. Each of these is an example of a monomial. And you can see there's no plus or minus signs. It's one term because everything is multiplied together if there are more than one thing. So understand that if we have the monomial, I don't know, 3xy squared, as I said before, this is called the coefficient. And it tells how many, in this case, how many xy squareds there are. And x and y could be any number, but an xy squared is a special number depending on, I mean, as soon as I plug in values for x and y squared. I would never say, though, 3x 2y squared. That would never happen. There is always one coefficient, and it always goes in front, and it tells how many of this number, whatever that is, there are. We know that these are the exponents and these are the bases, but the point I wanted to make is about the coefficients in front. Let's move on to the whole idea of, and these are just one term, everything, no adding or subtracting because it's product, more than one thing. Let's go on to the notion of a polynomial. Poly, as you know, means many. Nomial. That means it's an expression with more than one term. And basically, the way you can think of it is the sum, which is the same thing as the difference, because subtraction is the same as adding the opposite. The sum of monomials. So think of it as many monomials. In other words, you can recognize that a polynomial is a polynomial if there are plus or minus signs in there. So here's one example of a polynomial. 2x squared plus 3xy plus 6y squared. Okay, this is a polynomial. You can see that there are addition signs there. And there are many terms. Each of these is a monomial. It's the sum of these monomials. In fact, this has a special name. And I bet if you thought about it, you know the root word for 3 is tri. So this particular polynomial is known as a trinomial. And from that, I imagine you can extend your knowledge to think this is a binomial. They are polynomials, but they have also a special name, just like a square is a special rectangle. Doesn't mean that it's one or the other, it's both. This is a trinomial that is a polynomial. This is a polynomial that is a binomial. So let's get on to the whole idea of simplifying polynomials, because that's what your homework is about tonight. Homework is about simplifying, and simplifying in this situation is just code for combine the like terms. As we saw in the example before, if I say 3x squared y, I'm not sure if this is exactly what it was, plus 5x squared y equals 8x squared y, you can see that when you have the like terms, as we showed before, if I erase these, they're exactly the same, including which exponents go where. The x squared is, the squared is with the x, the y. If there is no exponent, it's 1. So this is 3 and this is 5. We know these are like terms, so just like before, we add the coefficients, or subtract if it's subtraction, the coefficients, and the variables and exponents stay the same. So this is combining like terms. Notice that first you have to identify if they are like terms. You can only combine like terms. If they're not like terms, don't add them. So let's say we have a polynomial, I don't know, looks like 3x squared y plus 2x squared plus 5 plus 4x squared y plus 10. Okay? If I want to simplify, that's code for combine the like terms. So in this, I first want to see, do I have any other x squared y's? And yes, I do. And actually, I'm going to change this example. I want to make this minus, because sometimes the signs are the hardest part. So if I add positive 3x squared y and negative 4x squared y, what I have is negative 1 or negative x squared y. Notice that it is not like terms with 2x squared, even though there's an x squared there. If it's not exactly the same when I take away the coefficients, it's not like terms. This is an x squared y, and this isn't just a plain old x squared. So this one was a 3. Geez, I can't even remember what this was. So let's just say it's 2. I think that's what it was. So negative x squared y plus 2x squared, no like terms to combine it, plus 10. I'm done when I don't have any like terms in my answer, and don't go any further because you don't have like terms. Don't go further. We have no like terms. Only combine like terms. Your polynomial is simplified when you get to the point when there are no more like terms. So what about the notion of some of these problems that you had that are geographical? So let's look at an example. Let's look at one of these. We didn't do one of these in class. It was kind of a crazy day. But let's just say I have one rectangle that looks like this, one rectangle that looks like this, another that looks like this, and another that looks like this. So pretend that these all go together. If this is 2x, and this is 1, and this is x, and this is 2, and this is 1, well, across this is 2, and this is x, and down here is 2x. So if I wanted to think about what the area of this whole figure is, that is, the dots go all the way around, what I would say is 2x squared. That gives me this one. I've got 1x here. I've got 1, 2 here. I've got 4x here. And I have to add the 2. So after I do this, I combine the like terms, and I have 2x squared plus 5x plus 2. And that's it for today.